PreLab. So today we are just going to wrap up activity 4. I'm just going to show you what I've put in to guide you. Now, if you go back to module, okay, before we do that, I want to go back to the video of part C because I don't think we did that, and I want to give you a little bit more detailed explanation of that. So we go back over here, and here's the video. And I'm just going to scrub forward to the part where we look at part C so that you guys can see what's going on here. Yeah, there. And that is the objective of this experiment. Put it in your own words. What you guys will be doing is you guys will be using the Spectro-Vis component of Vernier. And if you press the space bar again, it makes this thing move forward. This is Spectro-Vis. This actually monitors the wavelength of your solution. It tells you the absorbance at different wavelength. So this right here is just white light, or for this particular chemical, it basically tells you it's different from a Spec 20. You guys were exposed to Spec 20, I think in Chem 200. A Spec 20 basically just tells you the absorbance at one wavelength. This particular device tells you the absorbance in the different wavelength. In this particular case, from 800 all the way down to 420 nanometers in this particular case. So this chemical right here, whatever this chemical is, has the greatest absorbance right about 580, 590 nanometers. This scale down here is in nanometers. So it has a maximum of 590. And what you do when you're trying to monitor chemicals, remember that the absorbance, according to Beer's law, is proportional to the concentration. So the more chemicals that you have in this cuvette, here's a cuvette in here, the higher the absorbance reading. Okay, but you don't want it too high because it saturates the instrument. You want it at a certain level. But if you keep everything the same, okay, then you can monitor the concentration based on the absorbance reading. And you want to monitor the absorbance reading at the highest maximum here, lambda max. That's because it's most sensitive in that area. It's the most sensitive in that area. When you guys do experiment number 1, you guys are also going to get the absorbance spectrum. This is an absorbance spectrum right here of methyl-viologen. That's the chemical we are studying, also known as crystal violet. Methyl-viologen is also known as crystal violet. It's the same chemical. Crystal violet is the regular name. Methyl-viologen is the chemical name. Okay, but you guys are going to be taking the absorbance of methyl-viologen, finding the absorbant max, and then setting the instrument to look at that wavelength as the concentration drops or increase, because now you can use that as a way to gauge the concentration of the species that you have. So in this experiment, we're going to sit at about 580, 590 nanometers, and we're going to use that to indicate what concentration is correlated to what absorbance. So here we have it right here in this second graph. What we have is, we know we have a set of standards. The standards are going to be 0.5 molar, 1 molar, 1.5 molar, and 2 molar concentrations. And we measure the absorbance. The lower the concentration, the lower the absorbance. These are absorbance all the way to up to about 1.1. Okay, so what we have is a calibration curve. And the calibration curve tells us for whatever concentration we have, it's going to have this absorbance. But we can work it backwards. If we have an unknown and we measure out its absorbance, then we can use this calibration curve to figure out what concentration that unknown has. Again, let me repeat myself. The calibration curve that you guys are generating with the knowns are going to have known concentration and then you're going to be measuring the absorbance for those known concentration. You're going to generate a calibration curve. From the calibration curve, you guys can do a linear regression and get do Linus on it. You can do Linus whenever you generate a line. Why is Linus important? Because it gives you the slope, it gives you intercept, and it gives you the standard deviation of those. It also gives you the y equals mx plus b. What you are given now is, you're given an unknown, and you don't know what the concentration is, but you're going to take that unknown and put it into the cuvette right here. I mean, the Spectro-Vis, you're going to put it in here, and you're going to read that absorbance. You don't know the concentration, but now you've read the absorbance, and you can use the calibration curve to figure out what concentration that unknown is. You guys are going to be graded for your unknown here, okay? So that's part of, well, again, you guys are watching the video, so you're not really doing a technique, but if you were in lab, this is how you would do it. Okay, this is how you would do it. And it's important that you know this if you haven't been exposed to it already, because you do this in organic chemistry as well. So let's move forward, and I'm going to just scrub forward, okay, on this. So here, I'm just showing you that I have a clean slate, and instead of sitting at an absorbance, I'm actually going to measure the whole spectrum for these different concentrations. And what you should see is the whole spectrum is going to be generated. And these are the concentrations: 0.01, 0.02, 0.05, and 0.1 molar. Okay. And here you can watch, and I'm doing this fast forward so that you don't have to like get bored of me actually doing this in real time. So this right here is, well, just watch the video. I think that was the lowest concentration. Okay, and here you can see the absorbance reading. I put the second one on. Okay, and then what you have to do is you have to put the cuvette in there and let it equilibrate so that it's in the same temperature as the instrument. Here's the second, and that would probably be 0.02. And then that's the third. And then that's the fourth coming up. And you notice there's multiple passes here. See how there's multiple lines here? It's because I'm running it multiple times. And what you want to do is you just want to take the instrument and go to a specific wavelength. So let's say it's at 380, and then just read the absorbance from that. And here I think I actually do sit at a certain absorbance. I can't see it right there because it's sort of 420. I'm sitting at 420 nanometers, and these are the different absorbance that are going to happen per solution with different concentrations. So if you look at this right here, you guys are going to see, again, I'm putting in the concentration, and then the instrument's putting the absorbance in this graph, and I'm generating hopefully a straight line. That's the last. Here we have it: 1, 2, 3, 4. I think I have to do this again because that was off. So that's what the experiment shows you. Okay, and then from here, I think you have the data set. You have the data set, and this is basically it. It's not quite a straight line, but you can basically use that calibration curve. So that was the experiment in fast motion. Okay, so I wanted to show you that. Let's go back to the module page, and let's talk about that part. Here is write-up for activity 4C, cobalt chloride. Now notice these are in different sections. And the reason why they are in different sections because I want you to put the pre-lab section on this page, you under student view, you're just going to click here and then start writing or paste whatever you have. And if you look here, I give you somewhat of a skeleton guidance. I don't tell you the details because you have to figure that on your own. I do tell you that this is the format I want. Heading, objective, background, procedure, pictorial procedure with the data table included, safety, and then any pre-lab questions. This is what I want. It's up to you to figure out the details of this part. You've already practiced with the first two. Here, I want you to, I'm weaning you off basically. Okay, once you complete this, then get out. I don't want you to put your post-lab, and I don't want you guys to put your post-lab or your data and observation in this section, only your pre-lab write-up. Then if you go back, let me do reverse. If you go back to the module and click on this part, this is where you would put your data and observation. Again, you can look at the guidance that I provide. I don't give you much. I just give you the skeleton, that these are the things that should be included. Use the worksheet as to what information you need to include in your data part of this. And then again, if you click on submit assignment, you can start writing your stuff here. And then if you're not done, just submit it. And then you can always go back and open it up again and continue from where you left off, as long as it hasn't passed the due date or the until date. Once it's past the until date, you don't have access anymore and you can't go back and revise it. I have to open it up for you. Okay, so this is where you would put your data and observation. This is the guidance of guidelines of your data and observation. And then if you need to do your post lab, let me leave this page, then you go to this section. And this is how I'm going to set up all your experiment. I'm going to give you 3 sections in each experiment where you can put your pre-lab, your data and observations, and your post-lab, so that it's clear to you, because these things are written as different segments. So again, here, click on this to open it up. These are the guidance. Again, it's not much of a guidance because I'm weaning you off on what to include in your post-lab write-up. Use the activity, the procedure in your lab manual to give you an idea of what is important, but you're always addressing what is the significance of this experiment? What did you learn from the experiment in your discussion? Okay, I tell you, processing the data and calculating the data, table of results is always here. Okay, and then the discussion, the conclusion is always the same. What was the objective? What were the results? You don't tell me anything new. You just sort of summarize the overall essence of the experiment. So that's basically this week's lab, activity number 4. Okay, you guys are not expected to do the experiment, so it's going to save you time. But I do want you to put your effort into writing up the report, so that your reports, when it comes to the real experiments, are going to be what I expect from you. Okay, looking at the chat, there's really no other questions, but yeah, these things, take a look at the deadlines. The deadlines will always be posted. If you look at the very bottom of these things, it'll always tell you what these things are actually on top. In this particular case, and then these different sections have points. This particular section is 4 points. It's due March 1st. If we go to the previous section, I think the pre-lab and the data and observations are worth 3 points apiece. Okay, so this is 3 This is 3. This actually is 3, not 10. I need to change that. So let me change that real quick. The PreLab is worth 3 points, not 10 points. Otherwise, this experiment would be worth. So let me just show you how I do that. I just go here, make that 3. Now the PreLab is worth 3 points. 3, 3, and 4 adds up to 10. This part is worth 10 points. Okay, so if I go back to modules, you'll see right here under 3, 3, and 4. This is 10, and this is 10. So that's all I have for you guys today.